Example problem 4 reads, a bubble of water with a surface tension of 0.068 Newton meters forms such that it has an integral gauge pressure of 13.6 pascals. A asks us how large is this bubble? So the problem tells us that we have a surface tension of 0.068 Newton meters, that we have a pressure of 13.6 pascals, and we're being asked for the radius of this bubble. So the formula that we're going to use for this is pressure in units of pascals equals the number 4 times surface tension measured in the same units of Newton meters divided by radius, which is in the same units of meters that length was in. So we're going to be looking for the denominator, and the rules to rearrangement say that you just simply switch places with the denominator and what's on the other side of the equal sign. So after rearrangement, we end up with the radius equals 4 times surface tension divided by pressure. And so we can go ahead and plug in all of our variables since they're all in their correct units at this point. So 4 times 0.068 Newton meters divided by the pressure of 13.6 pascals. So 4 times 0.068 divided by 13.6 equals a radius of 0.02 meters. And so that's the answer for part A. Part B says a surfactant is added to the water, reducing the surface tension to 0.021 Newton meters. If the gauge pressure inside the new bubble is the same, what would the radius in this case be? So everything about the situation stays the same, except the surface tension changed. So we can use the same formula that we rearranged, 4 times a new surface tension of 0.021 Newton meters divided by, it says that the gauge pressure remained the same, so we're going to keep that same pressure of 13.6 pascals. So in your calculator, 4 times 0.021 divided by 13.6, that equals a radius of approximately 0.006 meters. And that is the answer for part B. Thanks, and let me know if you have any questions about example problem 4.